Hello guys, today we're going to be looking at the three kinds of receptors in cell signaling. We're going to start here with GPCR, which stands for G protein coupled reception, or receptor, sorry. Should be using the correct words here, right? We start with a ligand binding to the receptor. And what that's going to do is that's going to change the shape of that receptor, and it's going to attract a G protein. So the G protein binds, right? It has GDP on it, right? So it's going to swap with GTP, right? This is more energetic. You can kind of think of this like ATP, right? It swaps that low energy GDP for the higher energy GTP. And what happens is the G protein detaches, and it's going to go over to a membrane enzyme, right? Usually not far from that receptor, and it's going to activate it, and a phosphorylation cascade or some sort of response will occur then. Alrighty, moving on, we're going to be looking at the ligand-gated ion channel. This one's pretty simple. You have a receptor here with an active site for a ligand, and the ligand binds, right? What that's going to do is that's going to open the channel here, right? It's going to allow ions to move through. Quite simple, right? We all know how channel proteins work. But it gets turned on by the ligand binding, right? That's important to know. And some sort of response using that movement of the ions or the presence of ions will cause some sort of response there in the cytoplasm of the cell. Alrighty, lastly we have RTK, which stands for receptor tyrosine kinase. This one is rather complicated, but I think it's the coolest one of both. So you'll notice we have two RTK monomers, right? It's just composed of that receptor and the tyrosine on the sides, right? We have 3 on each monomer. What you're going to notice is one ligand for each is going to bind to the active site of the monomers. And what that's going to do is it's going to bring them together to form an RTK dimer, right? So now you have this big old RTK dimer molecule, right? And it has 6 tyrosines on it. And what you're going to notice is ATP or ATP, which is the more fun way to say ATP. I like that. My bio teacher told me that one. Can't get out of my head. It's terrible. All right, so ATP is going to bind 6 of them. And what's going to happen is it's going to phosphorylate the RTK dimer. Right, it's going to become ADP, and the phosphates are going to stick on, and now it's phosphorylated. And when we phosphorylate a kinase or a receptor, it's going to become active, right? And you'll see a relay protein. That's just any protein that continues the transduction pathway, right? We have that relay protein bind to one of the phosphates and become activated, right? It's going to change the shape of it. And it's going to continue that transduction pathway. Well, that's all for you guys. Hope you guys enjoyed. Like, subscribe, anything to support. See you in the next one. Bye-bye.